the profile, it should be satisfy the law of gearing. Generally, we use only two standards, one for the sake of manufacturing. So cycloid is generated by tracing a point. For example, tracing a point on the circle that is rolling on a straight line without slipping. So this is not slipping, so this is rolling like this. So if I consider a point on this one, so this is a point, and at this instant the same point I will consider, even at this instant also I will consider the same point, and let's see how this circle is, how this generating. So here this is the point in this instant. So when the circle is like this is a point. So let's say this is the something like a a1, and this is the a2 at the position 2, and this is the 3, and this is the 4, and this is the 5, a5. So if I join all these points, so this is the curve traced by this point A. So this curve traced by the point A is called as a cycloid. So this is the cycloid. We have already seen the face and the flank of a gear. So if it is a tooth, and this is the pitch circle, and this is the face, and this is the flank, bottom one is the flank. So here the face is generated by epicycloidal, and the flank is generated by the hypocycloidal. So hypocycloidal and epicycloidal. What is epicycloidal? Instead of a straight line, now I am rotating this generating circle on the circumference of another circle outside. Then in that case, the curve produced by this generating circle at generating point is called as a epicycloidal. What is hypocycloidal? In the same scenario, if I rotate my circle inside the circumference of a circle, then this point will generate this point will generate one cycloidal, that is a hypocycloidal. In this case, what we consider is a pitch circle instead of base circle. So this is a pitch circle, this is a pitch circle, and the pitch circle at the top of this one, I will take one circle like this, and then I am rotating this circle to above the circumference outside. Then if I consider different points, what happens? So this is the one first position, this is second position, this is third position, and something like that. So if I trace this point, so it is something like this. And in the same manner, now what I do is, here I will rotate the circle inside like this. So here like this, and if I trace the point starting from this meeting position, this is a point, this is a point, and this is a point, this is a point. So if I trace like this is the one. So even though it's looking like this, actually it comes like this. So if I join like this, it would come like this, and here on the other side also it would come like this. So this is the full tooth profile. Here what we need to see is whether it's satisfying the law of gearing or not. So what is the law of gearing? In the law of gearing, the pitch point P produced when the two gates are in the engagement should be always a fixed constant. It shouldn't change its position. So that we can actually prove in this case that this is indeed a constant point. But here the proof is not required. And the disadvantage of this cycloidal profile is, here the manufacturing process is very cumbersome. Why? Because here we are using two types of profiles. Half is a hypo, and another top one is a epicycloidal. So because of this one, these became very absolute these days. ABSOLute.